Hello everyone, and welcome to the IT Logic 101 Troubleshooting series. In this series, I'm going to focus on giving you a glimpse towards how an IT professional thinks and how an IT professional addresses problems and troubleshoots one step at a time. I chose to start this series by going with the network troubleshooting. Reason being is that network is a very common topic in IT troubleshooting, and a lot of problems, even though if they're not related to network, has some network components in them. So you need to be aware of how to troubleshoot and get visibility towards what's going on in the network, especially because machines today are not isolated and they are connected to a network in one way or another. So I'm going to start by addressing some of the tools and giving you a really brief information on each one of them. If you need more information about them, you can Google them or go to the command line and use the question mark or the help, but they're pretty self-explanatory and I'll cover them now. The ipconfig/all is a very common command when you want to see the network configuration that exists on the machine. The /all flag will give you all the information on all the network cards and is very handy in one command. The ping command is a very famous command that is related to reachability. It's a command that you will issue from one machine to another machine to understand if there is network reachability from one side to another. The Tracert command, especially with the flag of the -d, is a command that allows you to test the hops, the network hops that a packet takes from the source address to the remote destination address to understand what are the various routes that the packet is going through, what are the various routers and default gateway that it hops through. And this is a command that you use to troubleshoot networking issues that are related to WAN or networking issues that are related to multiple subnets. The Arp D is a command that will give us information regarding the MAC address table and the resolve of the MAC address to an IP address and how they're connected. Every machine has a cache. The ARP cache has this information cached, but sometimes we have all kinds of issues and problems relating to either cache or a poison address that is become static on the machine. And this is a command that we're going to use either with a -a for visibility or -d to purge. The route print is another command that is related to understanding the route print of a machine. Often a machine will have a single route, a default route, but it's not necessarily the case all the time, especially on machines with multiple network cards. So the route print command will give us some visibility towards what's going on in the routing table of the machine and give us some understanding towards why a packet would take a specific route, especially in the multi-network cards environment. So as you can see here, I have client 1 and client 2 connected to a switch. Their IP configuration is listed in the tables next to them, but in general, 10.0.0.1 for client 1, 10.0.0.2 for client 2. They're in the same subnet of /24, and the default gateway is the same, but it's not really relevant for internal network communication. I've listed the commands at the bottom left that show that I'm able to successfully ping from client 1 to client 2. When I perform the arp-a command that show me the MAC address table binding to the IP, basically the ARP, it's listed correctly. And I can see that when I do the trace route, I am seeing no hops. There is a single hop between client 1 to client 2. And this tells me that connectivity-wise, everything is working as intended. And now you might ask yourself, why does the troubleshooting section starts with everything working properly? It is very important for you to be in the mindset of understanding when everything works. So when you're troubleshooting, you have a reference point to understanding what does not work. A lot of times, if you don't understand how everything works when everything is okay, it's very hard to troubleshoot an issue because sometimes what you think is broken is in fact the working process in day to day. So you need to have this understanding, and also it will give you tools to look for differences, like match the differences picture game, and really helps you when you're trying to troubleshoot something for the first time if you have no reference. So one last thing before we move on to the troubleshooting segment is to understand how the flow works when everything is working fine. So for example, if you take a look at the green dot in client 1, once everything is working, the green dot represents traffic going from client 1 to client 2, and once it reaches client 2, we have the return traffic going with the purple communication back to client 1. And this is what we expect and want to see. Because the flow goes two ways, there's a lot of places down the road that it might fail. Alright, so now we're going to start covering troubleshooting steps, and I'm going to start with the most basic ones, and then we're going to progress to the more advanced ones. What's important for you to take from this series is the mindset, the concept. What are the steps that I'm taking into? What are the things that you can incorporate in your troubleshooting logic to improve your process and also to actually gain something of experience based and not just these are the steps that I want to take, A, B, C, as a memorized playbook. So for starters, if I'm trying to communicate from client 1 to client 2 using the ping command or any other network utility, I might encounter an issue that will prevent me from even leaving client 1. And one of those issues, and this is an example here, if I'm getting the error message of ping transmit failed, general failure, then I might have a physical layer issue here. I might have a network card that is being disabled and it's not able to communicate because it's dead. I might have a network cable that is disconnected, or a Wi-Fi network that is disconnected if we're talking about the Wi-Fi option. And those things affect the fact that I'm not able to even communicate outside my machine. I don't have the physical resource needed in order for me to perform communication. Another thing that might cause this issue, and maybe some other similar error messages, is if I'm trying to ping something outside my network, outside my subnet, and I don't have a default gateway specified, which is a prerequisite. So having this error means that I'm not able to satisfy the first prerequisite for network connectivity, hardware level. Another error message, which is much more common, is the request timed out. And the sad part about request timed out is that it's not providing us with a lot of information. It doesn't give us a lot of feedback why it's not working. So I wrote down here a few steps that I'm going to take if I see this type of a request timed out. First of all, I'm going to verify the network configuration that I have on client 1. I'm going to see the IP address and the subnet. Those are my primary focus. See that there's nothing odd here and that I'm trying to actually ping the remote IP that is inside my subnet. And this is kind of a given for this type of same network, same subnet troubleshooting. The next point is to understand maybe the remote machine is down. Sometimes people forget, they turn off a remote machine, you try to ping it, it's down, and you're troubleshooting and for no reason because that machine is turned off. And that's something that you should, at least in some point, investigate or understand that it's actually up before you dive into much deeper troubleshooting. I'm not necessarily saying as the third point, but definitely down the road, verify it. And another question that often helps you and helps you narrow down the problem as well is it reachable from another machine? If I'm able to ping this device or this server from another machine, it might give me insight towards what is the issue. And this is something that with two pings that running from two separate machines, you might receive different results. And the difference in results gives us a lot of information that we can work with. The next point is the firewall configuration. By default, modern operating system and some of the older operating systems as well are blocking ICMP connectivity without anything. So if you're installing a fresh machine and you're not disabling the firewall or adding the ICMP exception, which is the ping protocol way of performing the check, then you might have a firewall being up and you're not able to reach it, and that's basically what's killing it. If you're using Windows, it can be the local firewall. If you're using a Linux distribution, there's IP tables, UFW, all kinds of other flavors. Make sure that the firewall is either down or you're adding the exception. If you're doing the troubleshooting, the easiest step is to just turn it off, and that will be the test, and then you can put it back on and add the specific rules. Another thing that is very rare is speed and duplex issues. If you have older equipment, older switches and stuff like that, you might have a problem where the speed and duplex kind of get mixed up, and then you have kind of a one side going as half duplex, the other is full, sometimes speed. That causes a lot of degradation in the network performance, and sometimes it might create all kinds of time downs on the network. I haven't seen it too much, but it is something to be aware of. And then you'll go to the advanced setting of the network card and hard code the network and the speed and duplex, or perform the negotiation again by disabling and enabling the network card. So now we're going to move another step forward and assume the traffic is able to leave client 1 and it's being blocked on the switch level. This is a very theoretical situation. Often this is not the case in most modern environments. The reason being is that a switch is a simple, or sometimes referred as a stupid device, and even if it's an advanced switch, usually on the layer 2 communication, everything is going just fine. It might broadcast if it's not able to forward the traffic to the correct port, but connectivity wise, everything should communicate, assuming same IP, same subnet for all the devices that are connected. There are some exceptions, and I'm going to cover them in this video, but for starters, the issue might be very similar. It might be the same error message when we're pinging from client 1 to client 2, request timed out, even if it's being blocked on the switch level, which kind of gives us no hints. We might see a different type of outcome if we're performing a trace, for example, and if we're seeing anything in trace that is more than one hop, this will already lead us to understand that we might have a subnet issue here, and that one of the subnets is not configured properly, and we're getting the traffic mixed up on the way because it's trying to go to the default gateway. Next thing we might want to test after tracing is to see the switch. Do we have the MAC address table correct there? Is the allocation of ports assigning to the right MAC address? And this is something that is often not really a problem, because if this MAC address allocation is not full, it will just use a flood if it's not able to find this MAC address. And really not much that we can test here. The next thing is that sometimes we're seeing layer 2 access list, and this is something that is pretty rare if we're seeing that inside the local network and it's blocking based on the MAC address or a very specific protocol. I would say that this is very rare. And the next one is also even rarer if we're talking about quality of service that drops it because the traffic is currently, the network is full, the congestion, and the traffic that the ICMP is classified as least important, and it might be dropped. And the last part is also something that is quite rare if we have an ARP cache issue or a static ARP that is listed on the machine, and we want to purge this cache using ARP -D or delete the static entry. I would say that this is something that is not really relevant unless we have a security issue in our network and someone is poisoning the ARP cache and does that sort of things, but also something to be aware of. So another scenario that I'm going to cover is what happens if the communication flow allows traffic go from client 1 to client 2, but client 2 is not able to return the traffic. And this is something that is maybe just as common as the first thing, but if you'll take a look at the output, the ping command looks the same from client 1 and client 2, and there's really no difference. If I'm trying to ping each one of the sides, I'm getting the same timed out issue. But thing here that will point me towards the right direction is that when I'm doing the view network configuration, I need to validate the subnet mask if I'm suspecting that this is the issue, but I would really not be able to tell if this is the use case or the first use case is in place based on the ping message error. And if I don't have Wireshark on the link, I'm not going to actually see that the traffic goes one way and it's not returning. It'll be very difficult to pinpoint this type of scenario. But the same logic applies. As you can see, we're going to check the subnet and the network communication on both sides. We're going to trace the traffic to see that it's not going through hops and basically uses the layer 2 connectivity. We're going to test firewall rules because they might be different from client 1 and client 2. We might have firewall rules going out and firewall rules going in. So both directions are important, both on client 1 and client 2. And then we're going to look at layer 2 access list on the switch and also perform some switch connectivity tests to see that we have indeed the correct MAC addresses listed on the correct ports. And the last thing is an ARP cache or an ARP static ARP issue on one of the machines, maybe only on client 1, maybe only on client 2, that might affect the connectivity and create this situation where we have traffic going from one side to the other. If I want to recap all of the troubleshooting steps that I've done, we can see that there is a great emphasis on performing the network level configuration test, seeing what is the IP address, what is the subnet, what is the default gateway and the MAC address, and what is the correct setting on both sides, or at least this is what we expect. Performing some kind of trace activities or pinging activities in order for us to get some bearing, and then performing some application level tests like testing the MAC address table in the switch, checking the firewall rules, layer 2 access rules, or all kinds of static entries in the ARP cache that is performed. And if you would take those steps one by one, or at least use some of the patterns that I've given you, you'll find a lot of network issues are being resolved much quicker than just aiming randomly at a solution. Hope this was informative to you, and if you have any questions or you would like me to cover more topics like this, then leave a comment and I'll do my best to answer.